Hi, this is Mohammad Sadiq Rahman. I'm now recording my learning or understanding about the assignment number 4. It is about Q learning. This is about a mountain car which is to be trained to do a successful work, and the work is to reach the uphill where the flag is held. So it can steer back and forth, and it will take some decisions whether it will move right or left, so that the reward is maximum, and so that it becomes successful to reach the top of the hill and reach the flag. So for that, this is our agent card is untrained, so it cannot take the decision whether it has to move forward or backward. But this is the video of the performance of the train car, which we are going to implement today. And it is seen that after some back and forth moving, it can successfully reach to the flag. Firstly, we have this untrained agent, and now we'll train this agent to do the work successfully. And for this, at first, we're importing some functions from scikit-learn, that is time random function numpy, and something for plotting the reward we are using matplotlib. And this is the mountain car agent, and the environment has been created from gym.meg website. So we have to train our agent with some observations, and according to observation, it will perform some actions, and on the basis of the action, it will be rewarded or punished some results. And by this way, it will learn how the reward can be maximized, or it will take a decision which action to be taken in the next, so that our reward gets increased, and the final goal can be achieved. So here the mountain car can have three actions. That is, it can push itself left, or it can push itself right, or it can don't have to do any push. So these actions are defined by these three variables, 0, 1, and 2. And for each state, we will see two observations. That is, what is the position of this mountain car, and what is the velocity. And based on these observations and actions, it will be rewarded some value. That is, if for any unsuccessful action, it will be rewarded with -1. And when it will be achieved, when it can reach the top of the hill, the goal is achieved, and its target is to achieve the goal as soon as possible. So each step it is taken, and it will declare the work is done when it will reach the flag. So at first we are just we are just initializing the action space, and we're taking random action. And for any random action, it will be rewarded with some output variables. What is the observation? What is the reward? And it will declare whether the goal is done or not, and other informations. So for example, we are taking random action. It is taking action number 2. That is, it tells the agent to push right, and the observation gauge, that is, it is the position of -0.58, and it is the velocity. These are the two outcomes of the observation. That's why the shape is 2. And as it has not reached the top of the hill, the reward is -1, and it is not declared that is the work is done. So done is false. And for the next step, the new actions can be taken is 3. That is, it has the possibility to move forward or backward or no push. And this is the limits of the variables observation. That is, the maximum value of the position can be -1.2, and maximum is -1.7, and minimum is that 0.6. So now we are just dividing, creating an array. That is, the position can have total 20 positions in between this range, and the velocity can also have 20 velocity within this range. And we are just linearly spacing. That is the total number of we are dividing the range in the total number of position observation in the linear manner, from, that is, -1.2 to 0.6. This is the minimum position, the maximum position, and we are dividing this position into 20 different positions linearly. And similarly, for we are doing this for velocity, from -0.7 to +0.7, we are dividing it in 20 different velocities, and we are just printing these velocities, and it is indeed successfully created an position array and the velocity array. And for this position and velocity, we are just creating Q table. That is, you have three actions, and for each action and state, we're just initializing is for 0. And as there are 20 by 20 arrays, so the total number of observation will be 400. And as for each observation, there can be three states. The total number of Q table will be 1200. That is for each state, that is for each speed, for each position and velocity, it can have 0 action, 1 action, or 2 action. So in total, the size of this Q table will be 1200. And agent should be trained with all the possibilities rewards, so that it can be well known what action to be taken in the next, so that the reward can be maximized. So now we are just defining a class variable, that is make discrete, that is take any observation as input, and gives the outputs of the position and velocity. And already we are want to find what is the action, next action should be. So we are defining another class variable, that is get greedy action. It takes the Q table states and observation and what action this from the input, and it just calculates the for each observation and action, it calculates the values, and the maximum values it calculates as a greedy action. Then what actions should be taken at each state? It takes another class variable. It takes exploration rate and greedy action as input, and from random to dot random, it just generates any probability from 0 to 1. And if it is less than the exploration rate declared, then it will take any actions randomly from 0, 1, 2. We're starting the exploration parameters, that is with 1, that is 100% with exploration, and then they will just decrease it by 0.999, and it will end if it reduces to 0.01, which is the minimum and maximum range. So in between, we are just defining that is for each episode, it will take 1,000 steps, and maximum episode will take as 50,000. And there is some learning rate 0.1, and gamma, this is the parameter of the Q value equation, that's 0.99, which we'll see in the next equation. So this is the equation, that is the QSA. This is the Q value of a state and a action, and that has to be updated each time. So this is the present state, present action, and for this state and action is a quality value, and alpha is the learning rate that we defined as 0.1, and gamma is another variable for this equation, and it will calculate the Q value for the next state and next action, and it will then decide what should be the next action, so that the Q value is maximized. So well, actually, we have to train this agent with that equation. That is, at any present state, it has to be predict the future state action and Q values, and by which it will take the next decision actually. So now we're starting the training the agent. That is, at first we're starting the current exploration rate as EPS start, that is 1, and we'll calculate the reward, and we'll count the total time to train the agent. And at first we are just initializing any value, that is time step is 0, there is no score or no reward, and it has not reached final position, so done is false. And we are just resetting the position and observations. So we're resetting the environment so that the observation will be some starting position, and we just create the current observation. And now we'll just train it until it has reached the top of this hill. That is, until it is not done, we'll just train our model. So at first, we just take any greedy action from the previous get greedy action class function, but it will take any input and current observation from the table, and this initialized current observation, and within this parameter it will find some greedy action, what action it should take, that is 0, 1, and 2. And then we just put current exploration rate and that greedy action found from the first class function. And finally, with that explosion rate and greedy action, it will select the action. So we have already got the action and our current observation. Now it has to predict the next observation and next action. So that's why we are just creating another next observation with make discrete class function, and it will give us next observation, and based on this next observation and q table, it will find the next action. And then the formula becomes the q table. This is the formula, that is q current state action equal q current state action plus learning rate plus reward of the present action plus gamma times the maximum of the future state and action minus present state and action. And we're implementing this formula just in these 37 and 38 number lines. Then we're just increasing our type step, and based upon the reward, we're just updating the score, and we're just defining the next object as a current object, current observation, and the loop will continue until it has not reached to the flag, that is it is not done. So by this way, the agent will be trained, and we'll just train it for 50,000 episode, and for each episode we will take 1,000 time steps. And finally, we're just printing the episode with some exploration rate that is being changed in each stage. That is, the exploration rate is changing between 0.01, that's the minimum value, and the current rate and the decay rate. And each has been declared before. That's a decay rate. That is, at first it will start from 1, then it will decay, and it will end at 0.01. And we are just train this agent, and we just print each agent for each episode. We are just seeing that is a explosion rate is decaying, and it is completing 1,000 times step each episode, and the score is updating. And as we see, the score is getting bigger. That is, the reward is getting positive for each consecutive episodes. So finally, the total training time it took is as the final time is 1748 seconds. And finally, the score is minus 238, that started from minus 1,000. Then we want to plot this graph, the reward versus episodes. Then we'll just calling the main functions to plot, and we just see that is a scale version of the episode. That is, we are taking 10,000 episode after each interval, and so it ended up to 50,000 episode, and the reward is at minus 232 that we got in our previous simulation. And now if we want to record this environment, so we have to install some different functions, different library functions with pip install and something. And then we just want to make some video of the agent, that is it is performing successfully. So we are just creating the environment if recorder env, and the starting value is it is not done, and current observation will come from the resetting value, and current observation it will make from make discrete function. And then up to if it is not done, the reaction of the next observation, current action, current action and next action will be calculated, and based on this the agent should be trained until it reaches the final point. And end dot play is the function to display this. So if we run this, we find that yeah, it is successfully done, and it gives a 4-second video, and where we can see that is the agent is trying to learn the which would be the proper steps for updating the maximum reward, and it can indeed reach the final point. So that was the priming thing that we just learned from Q-learning, that is the mountain car agent has successfully trained how to reach the final goal. Thank you. That's all for today.